Welcome to our YouTube channel. Today we'll be discussing contingency theory. Hope you like this video and subscribe, and also share with others. So there's this question. It says you are planning the manufacture of modification to an existing product. Your analysis has come to the following information. What contingency reserve could you use? So there's a project, then there's a contingency that you need to use there. So they're saying there's 20% probability of delay in receipt of parts with a cost to the project of 90,000. So there is a percentage there and the amount given. So you always have percentages and the amount given. Then you have that contingency cost, which we need to calculate. So in project management, contingency theory refers to practices of setting aside portion of project budget or resources to mitigate potential risks or uncertainties. So you're setting a certain amount aside so that you can mitigate risks. So the contingency is a buffer that allows project managers to respond to unforeseen events, changes, or errors that may impact the timeline, budget, or scope of the project. So you're looking at it in case of a risk arises. So you're looking at how much is the contingency that you can reserve. So it deals with issues of risk management, uncertainties, and budgeting itself. And so when a situation is a positive, when you're dealing with contingency theory, remember this. When the situation given is positive, then just know that number given to that is a negative. Come again. When the situation is positive, like when you're going to gain something, then just know that the number is a negative. But when the situation is positive, I'll explain. But when the situation is a negative situation, you have loss, or if it's a dire situation, then the number is what? Is a positive number. So here I'll put the amount. Here I'll put the amount. Here I'll put the amount for the project data. Here I'll put percentage. Then here I'll put contingency reserve, or cost contingency reserve. So I have those three columns here. So the first one says there is a 20% probability of delay in the receipt of parts with a cost to the budget of 90,000. So this situation that you're going to have a delay, there's 20% that you delay to receive the parts, and you have a cost for the project of 90,000. Is it a good thing or a bad thing?
Michael, you are breaking.
This saying there's a probability of delay. You order something that, but they will delay. There's a 20% probability that there will be a delay, and then there will be a cost of 90,000. Is it a good thing or a bad thing?
It's a bad thing.
Because it's a bad thing, it's a negative situation. So the number remains to be what? A positive number.
Yes.
So I'll put 90,000 there. Then the percentage it is 20%, so we need to change it to a number, so it will be 20 over 100, which is giving us 0.2. You see that? Then we go to the next one. So to find the contingency reserve this ID, we just have to multiply 90,000 times 0.2. So it will be 90,000 times 0.2, which is giving us that number there. The next one there is a 20% probability that the parts will cost 100,000 less than expected. So there's 20% that you're going to buy the parts, and those parts will cost 100,000 less than expected. It's a positive situation. You're going to gain 100,000. So that number becomes a negative 100,000. Then the probability there is 20%. So it will be 20 over 100, which will give us 0.2. So we'll multiply that times that there, which is giving us that number. Then this one says there is 25% probability that two parts will not fit when put together or when installed, coming to an extra of 6,500. So we have 6,000. It says there is a percentage, there's 25% probability that two parts will not fit together when installed. You install the parts, they are not fitting together. They will cost you extra money of 6,500. So it remains to be a positive number. So it's this 25% probability. So it will be equal to 25% probability over 100. Which is giving us 0.25. Then there says there is 30% probability that the manufacturer may be simpler than expected. So you save 20,500. So it will be negative 20,500 because the manufacturer is simpler. So you will save money there. Here there is how many percentage? 25%. So it will be 25% over 100. This is giving us that. Then the last one there says there is 5% probability of designer defect costing 50,000 rework. So there will be defect there, so you need to rework. You have to spend the extra, so you have 50,000, which remains to be positive number there. Probability there is 5%, so it's 0.2. It's 5 over 100, which is giving us that. Then these numbers you multiply each by each side. You have those numbers. So to find the total contingency cost, you add everything. So total contingency cost, you add everything. So you sum up everything. So it will be equal to summation of those. So negatives will subtract themselves. Positives will add themselves. So you have 3,000 there. That is the contingency used. So if you wish, you would still do open bracket 90,000 times 0.2. It's the same thing. Close bracket plus open bracket. It's gonna be a negative there. 100,000 times 0.2 close bracket plus open bracket. We have 30,500 times 0.25 close bracket plus open bracket. We have 0.25 okay, we have it's a negative 20,500 times 0.25 close bracket plus open bracket. We have 50,000 times 0.05. So that's what was needed for this question. Thank you so much for following through. Remember to subscribe and share the video. Thank you. Till next time.
So that was it on this question.